Assalamu alaikum warahmatullahi wabarakatuh. Good day, all of you. Hope you all able to hear my voice properly. So kindly send me a message that if I'm audible.
Yes, doctor, your voice is clear.
Okay. So today in this session, we'll be seeing Newton-Raphson method. Okay. So let us take one problem and try to solve it using Newton-Raphson method. So let me share my screen with you. Yeah, all of you, do you able to see my screen, white screen? Do you see white screen? Am I audible? Am I audible? Okay, great. So let us start. Newton-Raphson method for solving equations. So okay, so let's begin. Newton-Raphson method. So let us take one question. It says, yeah. The session is on record. Okay, it is on record. I'm recording this session. Don't worry. Okay, the question is, suppose root of function f of x is equal to x cube minus x minus 1 lies in the interval okay 1 comma 2. This is the interval given. So determine the root with Newton-Raphson method. Determine the root with Newton-Raphson method. Sometimes hint will be given that take the initial guess, okay, or do up to 5 iterations. You know that there are many ways in which you can stop this. Either they may ask you for doing 5 iterations, or they'll ask you find up to 3 correct digits, or they may ask you find solution with error less than 0.001%. Okay, so there are different ways in which I've already taught you about how to do all these things, right? So today we'll see Newton-Raphson method because it is a very fast convergence method, and it will take less iterations to come to a solution. So we'll deal it with the number of iterations. Okay, let us see 5 iterations and see the solution. What is the solution of this problem? So this is the given function. Given function is f of x is equal to x cube minus x minus 1. Since the root lies between 1 and 2, we have to take an initial guess. Okay. Sometimes in problem, initial guess directly will be given to you, and sometimes this interval will be given to you. If initial guess is given directly, so directly you will have x naught with you. If initial guess is not given, if the interval is given, you can find the initial guess simply as a midpoint of this interval. Okay. So you just find out the midpoint of this interval 1 comma 2, okay, which is nothing but 1 plus 2 divided by 2, which is equivalent to 1.5. So therefore your initial guess x naught is 1.5. Okay, now using this initial guess you have to put in Newton-Raphson method formula. So what is the formula for Newton-Raphson method? Let me write here. Newton-Raphson formula. Newton-Raphson formula. Okay, you can find out n plus 1th root if you know the previous root, previous iteration root, minus the function what has been given. Okay, f of x divided by the first derivative of the function f of x, f dash of x of n. Okay, this is the formula for Newton-Raphson method. So now in order to fill this, we will just construct a table, okay, so that we will record all our values there. So let me take this in red color, and here let us write the column names, and let us have 5 iterations here. Iteration number 1, iteration number 2, iteration number 3, and iteration number 4 and 5. Okay, so and here let us have just use the smaller sizing. Suppose here we'll take the value of n, just take the same width. Here we'll have n, and then next here you'll be having x of n value. Okay, and let us write f of xn value here. Okay, and then we will write what is the first derivative value if you substitute the value of xn here, and then you will find out the next root f of this is x of n plus 1. Okay, now it's on you. If you are interested in finding error based also, you can find error. So I'm leaving this up to you, as we have already seen many examples with error. So let me take these values.
Continue, ma'am.
Okay, so now let us see we will fill this table with the help of our calculations now. So it is given that f of x is how much? F of x is equal to x cube minus x minus 1. Okay, so now we will find out the derivative of f of x. This is f dash of x. You know that the derivative of x power n is n into x power n minus 1. That is 3 into x power 3 minus 1 is 3x square, minus derivative of x is 1 and derivative of constant is 0. So I get the f dash of x value as 3x square minus 1. And we also got the initial midpoint x naught is equal to 1.5 also. Okay. So now let us take the iteration when n is equal to 0. When n is equal to 0, x of 0, you will get x of 0. What is x of 0? It is 1.5. Okay, 1.5. Now, how you will find out the value of xn plus 1, which is nothing but x1. Xn plus 1 is nothing but your x1. You will find out with this equation x naught minus, okay, f of x naught by f dash of x naught. How you got this formula? You just put n is equal to 0 in this equation. If n is equal to 0, x1 is equal to x naught minus f of x naught by f dash of x naught. Okay. So just you put the value of n is equal to 0 in the above Newton-Raphson formula, you will get this equation. So now we know the value of x naught is 1.5. Okay, and minus, now you substitute this value in the equation. Okay, f of x naught, that is f of 1.5 divided by, okay, f dash of 1.5. So this will give you 1.5 minus, okay, f of x is what? 1.5 whole cube minus 1.5 minus 1 whole divided by f dash of x is 3x square, right? 3 into 1.5 whole square minus 1. Okay, so tell me what is the value? What value you will get now? So what is f of x naught value? You have to simplify and you will get f of x naught. And when you simplify this value, you will get the value of f dash of x naught. Okay, so if I put 15 cube minus 1.5 minus 1, please use your calculator. Okay, I'm using the calculator here, and because you cannot see it, it's better after 1 or 2 iterations I'll show you on the MATLAB that whether these values are correct or not. Okay, so when we use the calculator or the tool for solving this equation, so f of x naught you will get as 0.8750. Okay, so I got some response. Yeah, he got 1.701. Please check it. Okay, now divided by f dash of x is 5.7500. Okay, so when I divide 1.5 minus 0.8750 by 5.7500, okay, so I will get the answer as 1.3478. So somebody else also has got, you're giving the answers 0.1 and there is some discrepancy with your answer and my answer. Don't worry, we will see with MATLAB and verify whose answer is correct. Okay, so as of now, just bear with me. Now 1.3478. Okay, Now you can find out error very easily. For first iteration, I will show you. The new value is 1.3478 and old value will be 1.5 because we have taken as x naught. Okay, and this is the absolute value. So old new value minus old value by new value, okay, into 100 will get you the error. Okay, so find out this error. I'm just leaving up to you. So in the first iteration, I got these values. Okay. And one of our friends in the class, he has got some other value. Let us see, okay, what values are correct. Now I will go for iteration number one. When n is equal to 1, put this value n is equal to 1 in this equation. Okay. So x becomes xn plus 1 will become x2 is equal to x1 minus f of x1 by f dash of x1. Okay. So I just put now here, this is for n is equal to 0, we have done these calculations. Now we'll make n is equal to 1. Okay. When n is equal to 1, so I get the value of x2 is equal to x1 minus f of x1 divided by f dash of x1. Okay. So x1 value already we have got it right here. What is the value? 1.3478 minus, now f dash of, sorry, f of x1 is, you have to put the same value, 1.3478 divided by, okay, 1 f dash of 1.3478. Okay, now you just find out what values you will get. 1.3478 minus, okay, what is there in the numerator and denominator, just find out. Okay, this is, I just show you here. Okay, this is your numerator. Okay, and this is your denominator. Okay, so you get numerator by denominator, you will get the answer. So some of us is giving the answers. Okay, so let us check what Ahmed Khalid has given the answers and what we calculated. Is there any discrepancy or not? Let's go to this MATLAB now. Okay, now so I need your attention here. You see, uh, let me work with it. Okay, so I have a function. What is the function? F is equal to x cube minus x minus 1, correct? So I write f is a function of x, and this is x cube. This is a MATLAB way of writing x cube. X shift symbol and press 8. Okay, this will give you a cap. This is called x cube minus x minus 1. Okay, so now we got this f of x. In order to find out, and also we know that our initial guess we have found out to be x naught to be how much? It is 1.5, correct? Let us give that value also. X naught is 1.5. Now what I will do is I want to find out f of x by substituting the value of f of x naught. Okay, so how do you get this? For that, first let us get f of x. So I will take f of x function in z. Z is equal to f of x. I think it will give you error because yeah, it gives you error. Why? Because z is a function of x which is taking from f of x, but we need to give a symbolic notation for x, that these functions are in terms of x. So I just define this and then again I write the same equation. Now this is working. Okay, so my f of x is now in z. Okay, my f of x is present in z. Is it clear? Now I want to find the differentiation of f of x, that is differentiation of z. My f of x is z here, right? So how do you find out the differentiation of f of x? There is a function in MATLAB called diff. Okay, so just you write diff of z. What is my function z? So it is clear from here. My z is x cube minus x minus 1, which is same as my function f of x, correct? So now z is having my f of x function, x cube minus x minus 1. Now I am differentiating with the help of this function diff in MATLAB. So it should give me the answer as 3x square minus 1. Okay. So let us see. So it has been verified that 3x square minus 1 is the derivative of our function f of x. Okay. So now how do you find out? How do you find out now f of x value? Okay. See here, we got f of x is 0.8750 here. Okay. So how do you get? So in f of x, you need to substitute x naught value, right? That's why you have got this value, right? F of 1.5. So how do you do this substitution in MATLAB? This is a very important problem. Okay. This you will do substitution with the help of a function called, I'll just show you. You see, we have substitute subs, okay, in function z, which is a function of x with value x naught, value x naught. But it will give you some p by q form. Okay. Now I don't want this answer in p by q in rational number. I want this in like if you divide 7 by 8, how much? So I will do typecasting. Okay, double or the same equation. Okay, same equation. I just write here. Okay, double of this. So it is giving me 0.8750, correct? So 0.8750. So I got some response. Yeah, who sent me the message? Yeah. So Ahmed, I think you have noted down. Okay. The answer is not 1.701. Okay. The answer is how much? What we have got, it is 0.875. Okay. Yeah, that's great now. Now you have got the right answer. Okay. So let's see now. Yeah, so I write 0.875. So what I will do is, similarly, this is called numerator, right? This is what? This is your numerator. I just write numerator is equal to this. Like as I have shown you here, this is our numerator, right? Numerator is f of x value. So numerator you got 0.875, correct? This is the numerator, you have got 0.8750, right? This is the new. What is the denominator? Denominator is f dash of x value you have to find out. So let us write the denominator. Denominator is also, I am just writing the same function, but this time I should not substitute in z differentiation of z, which is a function of x, and put the value of x naught here. Okay, so I got the denominator. What is the mistake? I missed one parenthesis. Okay, so 5.75 I got it. So what is the answer I got here? 5.7500 I got. Okay, so no problem, both are correct. So 5.7500. Now xn1 I can get it by solving x naught minus numerator by denominator, right? This is x naught minus numerator by denominator will get me the xn plus 1 value. So now let us see. Okay, x1 is equal to, okay, x naught minus numerator divided by denominator. So how much you got? 1.3478. Okay, 1.3478. So we got the answer. So all of you understood this first iteration? Okay, how we calculated the first iteration? Yes, great. So now let's go for second iteration. For second iteration, now I will directly put the answers from the calculator here, which is the calculator for me here in this session is MATLAB. Okay, so that you can also see the results. So I'm using this. So now we got x1 as 1.3478. Now I want to find out f of x1. That is numerator. Okay. So I write here x1 as So 1 point, sorry, let us change the color, same color, blue color. Okay. So x of 1 is, this is x of 1, right? So I got 1.3478. Now I want to find out xn. What is xn? This is numerator. So in this time, numerator, not x naught, it should be x1 value, right? So I will go here and find out the numerator. What is the numerator? This is the numerator. This should be taken as 1, not x naught. Okay. So in the numerator, I get 1.0068 value. Okay. So 1 point, correct. This is what I got the value, 1.0068 divided by. Now let us find out what is the denominator. This is the denominator, but I have to use the value of x1. Okay. So I get the denominator, which is equivalent to 4.499999. Correct? No, no, no. 4.4499. Okay. So 4.4499. Is it correct? 4.4499. 4.449. Yeah. So here I write. Now, how do you find out now x2 from this, right? So the formula is, yeah, this is x2. So x2 is equal to x1 minus numerator by denominator, correct? This is the equation. x2 is equal to x1 minus f of x1 by f dash of x1, right? So this value will give me this value. So now when I write this, I got 1.3252, correct? So 1.3252, that what he has given. I am at the right. This is the right answer, no? 1.3252. So I write here 1.3252. Okay. So let us write this 1.3252. I got here. Now let's take n is equal to 3. So when I take n is equal to 3, now I will write the direct steps. X cube, sorry, x3 is equal to x2 minus f of x2 by f dash of x2, correct? So now I have to find out, the x2 is already known to us, right? Now I have to find out the numerator now. Okay, how do you find out numerator? Numerator should take the value of x2 here. So I just write numerator value, which is 0.00208584. Okay, this is 1.3252, and this is 0. How much I forgot? 0.020584. 84. Okay, 0.020584. Okay, and let's find the denominator. Okay, denominator with value of x2. Why I'm putting x2? Because you see we are using x2 in the iterations, right? So I get 4.2685. 4 point. Okay. So now let us find out. Okay, x3 now. So this is x3. Now x3 is nothing but xn plus 1 is xn minus 1. This is x2 by numerator by denominator. So you'll get 1.3247. I think I got some response also. Very good. 1.3247. Okay, I got this answer. So let us write that 1.3247 is the answer. 1.3247. Okay. Now, after getting this, in the fourth iteration, okay, this is the value 1.3247. Now in order to find out the fifth x5, okay, we have to again put the value n is equal to 4 here. So when I put n is equal to 4, so x5 is equal to x4 minus f of x4 by f dash of x4. Okay. So here we got 13247. So directly we got the value, and I put n is equal to 4 here. So this is x5 is equal to x4 minus f of x4 by f dash of x4. Okay. So now let us find the same thing. We got, sorry, x3. We got x3. So now this should be x3. Okay, please correct it. Sorry, I was one step ahead. Cut. Yeah. N is equal to 4. X4 sorry, this is n2, n2, this is 3. Okay. We see x0, x is equal to 0, 1, 2, and this is 3. Okay. So this is 3 and x3. So x3 is equal to, what is it? X2. Yeah, this will become 4. Okay, sorry for that. So xn plus 1 is x power 4 is xn is x3 minus f of x3 by f dash of x3. Only first iteration, if you understood, all are repetitive steps. Okay. So now let us find out x4. So for finding x4, let us first find out the numerator. This numerator, I have to put the value here x3. So I get, okay, some value into e power minus 7. Okay, so I got some small value here. Okay, so 9.2438 into 10 to the power of minus 7. So it is 0.0000 like this. Okay, so I got some value. So let me directly write the answer. So this is the numerator value. And where is the denominator value? This is the denominator. We take x cube. Okay, this is denominator value. Okay, and then we will write. So let us write this 9.2438. And this is 4.2646. Okay, and then we'll find out x4 should be x3 and it should be x4. I think I got some response. 1.3247. Okay, so we get again 1.3247. See, in this case, the new value is 1.3247. Old value is also 1.3247. You will get 0% error. So all digits are correct here. Okay, so you can stop here. If you want to go again, you can go, no problem. Again, you will get 1.3247. So this will be the solution for this. Okay, yeah. So yeah, 1.3247. That's great. Now, sometimes there is one problem that if it is giving me answer only in 4 digits, 1.3247, and one of our friends is giving many digits. If I want more digits, you can do this in the MATLAB with the small setting. For example, I write format long G, okay, and then the same calculation. If I do, you see how many 1.3247179. It's giving me up to how many digits after decimal? 1, 2, 3, 4, 5, 6, 7, up to 14 digits it is giving, right? Yeah, up to 14 digits. So is it clear? So this is how you can solve the problem, right? Now I will give you some exercises you can practice on, but I will. These are not simple problems. This will be consisting of some transcendental functions. So I'll just share with you. You try with this, and I'll show you that what is the differentiation of this uh, equations also. So let me write this function. Okay. Yeah. Wait a minute. Yes. Okay. So you can try out these questions that if f of x is e per x minus 3x square. Okay, so you have to find out f dash of x, which is e per x is what? E per x only, right? Minus this is 6x. Okay, and second question, let me give something. mm, Yeah, let us x sine of x minus e per x. Okay, so now you have to find out f dash of x for this. Okay, now let us ask our MATLAB to find this. Okay, I will call this as function f1 and this is function f2, so that you know what is the differentiation of it. So what is q1? What is this q1? I didn't get. Yeah, question one. Okay, no problem. So here I write f1 is a function of x, and this is what is the function we have given? E per x minus 3x square, right? So e per x is written as like this, exp of x minus 3 into x cap 2. Okay, this is given. So now in z you can take this f of x. Okay, this is z is x cube minus x minus 1. No. Oh, sorry, I have to write z is equal to f1 of x, right? So this is exp of x minus 6x. No, it should give me 3 into x square, right? It is giving me differentiation. It should not. So let me clear all then write again. F1 is a function of x, exp of x minus 3 into x cap 2. Okay, so I write since x z is equal to f1 of x. Yeah, now exp is 3 into x square, right? So I will write now differentiation of z is differentiation of z. It should give me exp of minus 6x. This is the differentiation of f of x. Okay. Now another thing is here you are having both sin x and sin x. You will get UV rule. Okay. First differentiate this and write it, and then differentiate this and write it. Sin x differentiation is cos x. So first you will get uh, 1 sin x plus x cos x, right, for this. And e per x definition is e per x only. So let us verify that also. For that, I will write another equation f2, or I will just clear all this, and then I will write f2 is a function of x, and what is the function? X into sin x minus exp of x. Okay. So since x, and I write in z f of x, sorry, f2 of x. So, and in differentiation of z, I will write def of z. Now you get this value you see here. Sin x is first differentiate d by dx of this is like this here. U dash v plus u dash v. Right, you'll follow. First differentiate it x. So 1 dot sin x plus x is same, sin x derivative is cos x minus e per x. This is what we have got, right? This is what we have got. But the order is doesn't matter, right? This is what we have got the terms, right? So use this two functions for using Newton-Raphson method, and assume the initial guess to be 2, okay, and try up to 5 iterations. Let us see. Okay, so with this we have finished Newton-Raphson method. So if you have any questions, please ask. Any question? Everything is here? Okay, thank you very much. So inshallah we'll see next week secant method. Okay, so we'll stop here and continue next week. Thank you.